Review of angles in standard position and intro to vectors. We have the sine of theta is equal to the leg opposite over the hypotenuse. You can also write this as y over r. Cosine is adjacent over hypotenuse, x over r, and tangent is opposite over adjacent, which is y over x. Recall that Pythagorean's theorem is r squared equals x squared plus y squared. Here we have the initial side. If you want to draw the xy, you would have something like this. So your initial side is always going to start on this x-axis right here, and then it's always going to go counterclockwise. And this is going to be considered your terminal side. So if we draw down an angle, this length is x, this length is y. We have a right triangle, and this is r. So x squared plus y squared equals r squared. And then this is the angle you're looking for. Remember, we have SOHCAHTOA. So sine is opposite over hypotenuse, which is y over r. And that's how they got y over r up here. Cosine, adjacent over hypotenuse, which is x over r. That's how they got x over r. And then tangent is opposite over adjacent. That's how they got y over x. Right here. Alright, so let's work on an example. The terminal side of an angle in standard position passes through the given point. Sketch the angle, compute the distance r from the origin to the point, and write the three trig functions of the angle and find the angle. Okay, so we're going to draw our x and y. Terminal side, so we have a line here, theta. It passes through this point. So 1.74, 2.88. So our x is the length here, and our y is this length. So we sketch the angle, and now compute the distance r. This is your r, so use Pythagorean's theorem. When you square root both sides, you're going to get r equaling 3.36. Then write the three trig functions of the angle, and then find the angle. So we have sine of theta equaling y over r, cosine of theta equals x over r, and tangent of theta is y over x. You could reduce these fractions if you want. Now you can take the inverse of any one of these, and your angle will end up being 58.9. This may be a little off because of rounding, but as long as you're pretty close to 58.9 degrees, that is the correct answer. So you would take cosine inverse of 0.517 to get this, or tangent inverse of 1.66 to get this, or sine inverse of 0.856 to get this angle. Any three will work. Introduction to vectors. Let's start with scalar. Scalar is written as x, y. Scalar is used for mass, time, volume, etc. Scalar right now, that what we have known, does not have a direction. But once you find the hypotenuse, so resultant, it now has direction. Let's move on to vectors. Vectors have both magnitude and direction. It is written as r angle theta. R is your magnitude, theta is your direction. So for example, say we had 923 pounds at an angle of 18.4 degrees. This is used for velocity, acceleration, force, and weight. If we think of the equation F equaling m times a, we have your force equaling mass times acceleration. Notice mass is scalar, but once you times it by acceleration, which is a vector, you will get force, which is a vector. Vectors are represented by bold lettering. You can see that bold V right there. In your homework, they will denote vectors by an A, and it will not be bold. In vectors, the magnitude is the hypotenuse. All right, we have a vector V. Its magnitude is 248 pounds and is directed at an angle of 38.2 with the level ground. So if you recall, magnitude is the hypotenuse. So 248. With the level ground, it makes an angle of 38.2. Find the x and y components of the vectors. So we want the x and y. If you recall, we have cosine of theta equaling x over r. We have theta and we have r. So we can do cosine of 38.2 degrees equals x over your r. When you take 248 times the cosine of 38.2 degrees, you're going to get what the value of x is. That is 195. And then we can do the same with sine, because that is y over r. We have our angle and we have our r. So sine of 38.2 degrees is equal to y over 248. Take 248 times the sine of 38.2 degrees. You should get y equaling 153. If you're not getting these answers, make sure your mode on the calculator is in degrees, not in radians. We have a cable that has a force of 558 newtons at an angle of 47.2 with the horizontal. Resolve this force into vertical and horizontal components. So this question is basically asking what the question up above says. Vertical and horizontal are your y and x components. This 558 is your r, and this is your theta. So if you want a visual, this is 558 newtons. This is 47.2 degrees. We're looking for this x and this y. So cosine of 47.2 is equal to x over your r. And then sine of 47.2 is equal to y over your r. So when you solve, you get x equaling 379 and y equaling 409. The magnitudes A equaling 485 and B equaling 627 are two perpendicular vectors. Find the resultant and the angle that it makes with B equaling 627. So we always want to start on the x-axis. We can put either A or B here. I am going to put B here because we want the angle the resultant makes with B. The resultant will be somewhere in between A and B. So A is 485. Perpendicular means right angle. So our resultant will be somewhere in here. So let's make, for this one, it will be a square. So that means this is 90 degrees. So this angle is 90 degrees. This length is also 485. So let's find our resultant. So r squared equals 485 squared plus 627 squared. Then take the square root. So r equals 793. Let's find the angle between B and the resultant. That's what we're looking for. So we're looking for this angle. We have opposite over adjacent, so tangent of theta equaling 485 over 627. When you take the inverse of tangent of this fraction, your angle is 37.7 degrees. And if we write it in the form of our angle theta, it would be 793 angle 37.7 degrees. And the last example. The x component of A is 73.5. The y component of A is 59.3. Because this, again, is our initial, and our terminal is that magnitude that we're looking for. And this is going to be the direction. So you can use Pythagorean's theorem. Take the square root. So r should equal 94.4 degrees. And then to find your angle, tangent of theta is your y, so 59.3 over your x. I'll show you how to do this on your calculator. Here's your mode button. I'm in radians, so I want to go to degree. Then we go to tangent inverse of 59.3 divided by 73.5. Remember, we use inverse whenever we want to find the angle. So the angle is 38.9 degrees. Oh, this r should not have a degree sign. Final answer is 94.4. The angle 38.9 degrees.